Hello.
Hello.
Did we have any homework?
Not today. I mean, not
Okay.
for today. You're going to have for next time.
Okay, making sure.
Yes. Any other questions? We have 1 minute to answer any questions you guys have. Okay, did you guys read all the notes I gave you for your exam?
You said notes for the exam?
Yeah. You know, when I'm sending you the grade, I'm putting notes, comments. Are you getting them? Are you looking at them?
I got to see can you hear me?
This is Michelle, right?
I got to see my notes for the exam too, but I haven't seen anything for quiz number 9.
Oh, yeah. I keep reminding me. This is one I'm forgetting. Okay, yeah. Anybody else? This is my mistake. I'm forgetting because I have a lot of exams to grade now. I'm forgetting the quiz, but I will take care of that. Anybody else? Please go over the comments I give you for the exam. It's crucial. Otherwise, you won't learn your mistakes. Okay. All right, so we're gonna start today in videos. Okay. So today we're gonna, all right, let me see if I can make this look better. Yep. Let me fix the light, I forgot. Okay, so today we're gonna finish section 3.4 and we're gonna start chapter 4. So before we start doing, you know, the math stuff, let me talk what is it gonna be about today. The first part is gonna be about the following idea. Suppose you invest money in the bank. Okay, let's say whatever, $10,000. And suppose you invested annually. It means you get an interest, let us say, of 6% once a year. It means after a year you get 6%. Versus investing it compounded, monthly, let us say, 12 times a year. So we know that when do we make more money? The compounding or annually? I want answers, use the chat or in-note and answer. What? Compounding, we're gonna make annual. We're gonna make definitely more interest. So if you put it compounding 12 times a year, because we get interest on the interest, we get actually more money. So if the interest is 6%, compounded monthly, it means effectively we make more than 6% after 1 year because of the compounding. So we don't make 6%, we make a little bit more because we're making more money than we would have made if it were annually. So we're going to get a little bit more than 6%. So the question is, what is the effective rate? It means effectively how much interest I'm getting per year if the interest is compounded monthly. So effectively, how much I'm getting? I'm getting more than 6%, but exactly how much I am getting. We're gonna call this the effective rate. It means how much we are actually getting. But how are we gonna find this effective rate? Are you with me? Mm-hmm. Everybody? So now how are we gonna compute this effective rate? And that's really what I'm gonna talk about by really going through an example. Okay, well, how are we gonna actually find? So I'll start with the example, and when I find I'm going fast, I will actually slow down. And please, on the chat, tell me what you see, what you don't see, so I can work with you. So supposedly we have $10,000, and we invest those in a bank that pays an interest of 6%. And the interest is actually compounded monthly. Then my question is, effectively, how much interest I'm getting after 1 year? More than 6%, but how much?
6.16.
Okay, we have figured it out. All right, so assume the interest is compounded monthly. Then after 3 years, the formula that we developed last time tells me it's going to be 10,000 times 1 plus 0.06 over 12. 12 is the number of compounding. 0.06 is my 6%. And I'm going to play a game that you're going to hate, but actually you should get used to it. I'm going to rewrite this expression in the form 10,000 times 1 plus 0.06 over 12 to the power 12, the whole thing raised to the power t. I know that you don't like that, but is it correct mathematically? What do you think? Now I'm addressing everybody. Are those two correct?
Yes.
Yes.
Yes, because what we're doing here, when you have, as I said several times in class, if you have an to the power m, what you do is multiply the power. All right, and that's exactly what this is. 12 to the power t, it's the same thing as 12t. But now this is gonna give me, I'm gonna compute the term in between this term, and this will become 10,000, 1.0616 to the power t. So I'm basically manipulating the formula. Now, why is this important? What does this tell me? Okay, this tells me the following. After 1 year, how much money we're gonna have? We're gonna have 10,000. When t is 1, 1.0616. So by how much did the money grow? What's the growth factor in 1 year? The growth factor is 1.0616. So that's really what my growth factor is. So my growth factor now is 1.0616. Because after 1 year, that's how much money I made. The original times 1.0616. So my money grew by a factor of 1.0616. So what is actually my effective rate? So after 1 year, that's my growth factor. So it means effectively, what was the interest on my money? Sorry, I'm trying to get rid of the sun, which is shining on the paper. So now my question to you, if this is the growth factor, it means what is the actual interest rate you're getting on your money after 1 year?
6.16.
6.1. Exactly. That's what your classmate said at the beginning. Actually, I'm getting 6.16%. Okay, so that's really how much, that's exactly how much interest I am getting. So this tells us that, so only knowing what happened after 1 year, so this tells me that the growth factor is 1.0616. It means the rate is 6.16%. And now bunch of names, so what does this mean to us? This means that an interest rate of 6% compounded monthly yields the same amount as an interest rate of 6.16% compounded annually, that is once a year. So if you go to the bank and the bank tells you 6% compounded monthly, it's high, you know, you're gonna ask the bank, it means what per year? Because that's what you actually would like. That's what they call the yield. That's exactly what you wanna know. 6% compounded monthly, it's very nice, but you are really, to make sense for you, you should ask the bank, what do you mean per year? Per year means 6.16%. The 6.16 is called the effective rate, but that's the effect, that's the rate you're getting per year. The 6% is called the nominal rate. So that's really the language we use. So the 6% is the nominal rate, because that's not how much you're getting per year. The effective rate is the 6.16, because this is really how much you're getting per year. So how do we find the effective rate in general, and how do we find the growth rate? Sorry, how to find the effective rate? First, what I want to know is the growth factor. The growth factor after 1 year will be given by this quantity, 1 plus r over n to the power n. This tells you the growth factor. I'm sorry, I forgot to turn the light on. This tells you the growth factor. It means this tells you by which factor your money will be multiplied every year. Once I know the growth factor, the growth rate, I can find it by taking away a -1. Okay, and this I'm trying to explain where this formula coming from. This formula coming from the following. After 3 years, that's how much money you have. If I rewrite it as P times 1 plus R over N to the power N, the whole thing to the power T, this will become the growth factor. Once I know it, it's easy for me to find the growth rate. So the growth factor and the growth rate are usually what you get when you go to the bank. They usually give you the growth rate that they call the yield. They tell you how much you're getting per year because it makes more sense to us. So let's do a small exercise because this is not really hard. Let's do a small exercise. So this is my problem. Okay, and you go to the bank. The first bank tells you, I'm going to give you an interest of 6.1% annually. The second bank tells you, I'm going to give you an interest of 6% compounded daily. So the first bank is giving you more interest, but it's compounded once a year. The second is giving you less interest, but it's compounded every day. So to compare those two banks is very hard just by looking at them. How are you going to compare them? This is more interest once a year, less interest every day. So how would I compare which bank is better?
Bank B is better.
What?
Bank B is better.
On what basis?
Because when you're compounding it, you're gonna put in all those exponents, and it's gonna come out to be more than 6.1.
Can you just by
every
looking?
day, because the number is gonna be 365.
Yes, but I will, by looking at it, I cannot say which one is better. The only way we'll be able to decide which one is better is by doing the following. Ask ourselves, effectively, how much is bank B giving me per year? If I know the effective rate, and then I will not be comparing apples and oranges. I will be comparing apple to apple. Because here, we know every year 6.1%. This is 6%, but daily. So to be able, so it's hard to compare those two. To be able to compare them, I would like to know what's the effective rate of bank B. It means effectively, how much is bank B giving me per year? Then I will be able to compare. All right, so to be able to answer this question, I have one way to do it. I would like to know what's the effective rate in bank B. So how are we going to compute the effective rate? The idea is that to compute the effective rate, we usually find what's the growth factor. It means every year by how much we are multiplying. So we need to find the effective rate. So first we find the growth factor. And here is 365. So the growth factor is 1 plus 0.06 over 365 to the power 365. And 1.0618. So this tells me that every year, my money between 1 year, that's year, and that's our money. Every year, my money will be gonna be multiplied by that. That's the growth factor. So what's the effective rate? The effective rate is, so effectively how much rate I'm getting? I'm getting it's 1.016 minus 1, 6.18%. So this means that an interest of 6% compound daily is the same thing as 6.18% annually. Now I can compare bank A and bank B. This one giving me 6.1%, but this one is giving me 6.18%. So definitely bank B is better. So that's how we compare rate. So to compare rate, just by looking at them, it's actually hard. So what we do is that we ask ourselves, what's the effective rate per year? If I know the effective rate per year, and then I can immediately compare two banks or two investment or whatever. So that's the idea of effective rate versus nominal rate. So 6% compounded daily, it's nice, but doesn't show me, it doesn't describe the whole picture because it's hard for us to know how much per year. Effective rate tells me how much you're actually getting per year. Compounded daily also have the advantage you can withdraw the money anytime you want. Right. Now, part two. Part two is the idea of continuous compound. So what's the idea of continuous compounding? All right. From what we've done before, suppose I have those 10,000 and I'm investing them. Those annually, monthly, daily. We know that more we compound, the more money we make. So if you compound them daily, you get more than if you compound them monthly. And if you compound them hourly, we get more than if we compound them daily, and so on and so forth. So the more we compound, the more money we make. And it means the growth factor each time and the effective rate is actually getting higher and higher. The question is, what's the maximum possible growth factor or the maximum possible effective rate? It means if you compound, if you start with 10,000, the interest rate of 6%, and you keep compounding, what's the maximum possible effective rate you can get? So daily, we got 6.18%. Now, if I do it hourly, every minute, what's the maximum I can get? So that's what continuous compounding. You keep compounding all the time, and how much money you will eventually make. And to be able to answer this question, we have to introduce one of the most important number in math, which is the number E. Without the number E, I cannot really talk about that. So, and actually that's how the number E came to be. It's from studying compound interest. So the number E, what is the number E? It's a number. That's question number one. So E is just a number. It's like pi. You guys are all of you familiar with pi. And we know that pi is just a number. It's not a symbol, it's a symbol for the number 3.14, etc. There is another number in math, equally important, and it's the number E. And the number E, very important, and it has a name, it's called the Euler constant. Euler is basically one of the most famous mathematicians of all times. And the number E is in honor of his name. And so it's a number. So it's equal to what? What's this number? All your calculator will have the number E, and this number is 2.71828, blah, blah, blah. I keep going. It doesn't terminate. But it is actually a number, and that's crucial to keep reminding you it's a number. So let us a little bit work with this number for a few minutes before I go back to the main idea today. So suppose I look at the function f of x equal e to the x. All right, so that's an exponential function because e is a number. It's nothing weird, it's e is a number. So the same way, if I write to you f of x equal, let us say 1.2 to the power x, you tell me that's an exponential function where the cofactor, where the growth factor is 1.2. So when somebody write f of x equal e to the x, it really look like confusing because e is a symbol, x is a symbol, but it's not. It means basically 2.718 to the x. That's exactly what it means. So it's nothing more than a number, and that's crucial to understand. Very crucial. That is not a symbol, it's a number. So let us compute some values just for the sake of familiarizing ourselves with this number before we work with. So I'm gonna make a chart and start computing those numbers. So x equal to 0, f of 0 is e to the 0. Anything to the 0 is 1. Okay? 1. What's f of 1? E to the power 1. What's e to the power 1? Again, I'm emphasizing the fact that I'm dealing with a number, not a variable here. 2. What's e to the 2? It means basically you're taking this number and squaring it. Now 2.7 and you square it, of course, you pick up your calculator to do that, you're gonna get 7 point something. So it's just a number I don't want you to be afraid of. What if I put -1? What's this? E to the -1. But what's e to the -1?
Would it be the inverse?
Exactly, it's 1 over e. So it's just a number. I'm repeating over and over, it's a number. It means 1 over 2.718. That's what it is. What's 1 over 2.78? I really don't know. It's almost 1 over 3. And we pick up our calculator and we compute it. That's what it takes. So it's 0.367. So it's just numbers. Again, I do -2. E to the -2. E is a number. It's 1 over e squared. It means 1 over 2.718 squared. That's what it is. And then we can compute this number. So e is just a number. It turns out to be one of the most important numbers in mathematics. And we can talk about the function that take input x and spits out e to the x. And the graph of it, based on this picture, is going to be at 0, it's 1. At 1, is going to be more than twice, 2.7. And at 3, is very high. At -1 is 0.3, it's right here. At -2 is right here, and it's going to look exactly like every other exponential function we've seen. Okay, but the base e is bigger than 1, or the growth factor is bigger than 1, is going to increase. Okay, so e is a number, and we can graph the function f of x equal e to the x the same way we graph every other exponential function. Where this number originally came from, even though later on people use it a lot, is from the idea of continuous compounding. Let us talk a little bit about that. So what's really the idea? Okay. The idea is the following. Back to continuous compounding. What we're going to do is we have $10,000 and we're going to invest them at an interest rate of 6%, compounded more and more often. So every time we compound them more, and I'm going to look at what's the growth factor. So it means by what factor they grow every year. Because if I know the growth factor, I know the growth rate. So I know by how much it is. So let us do that very slowly. All right, compounded annually means once a year. So it's 6% compounded once a year. It means the growth factor is 1.06. True or false?
True.
True? Once a year. Nothing. That's the basic case. So that's how much the growth factor. It means the rate here is 6%. It's once a year. Part 2. I'm going to compound it daily. Daily. If I compound it daily, what is the growth factor? It means by what factor is going to grow every year. Now, I gave you the formula, but I'm going to rewrite it to remind you. It's going to be divided by the number of compounding to the power 365. That's the growth factor. Means every year we're going to multiply by this amount. Now we pick up our calculator, no more, no less, and we compute this number. And are we going to get more than 1.06 or less?
More.
Definitely we're going to get more because we're compounding it a lot. So I did the math, and I've been a little bit picky about the number of digits because it's very important. A lot of digits. So basically it means every year is growing by a factor of 1.0618. It means the rate, we're going to estimate it at 6.18%. But now I'm really interested in the growth factor. The rate, I will talk about it later. All right. Suppose I keep compounding. I compound every hour. All right. What's the number n now? What is n?
It's gonna be 365 times 24.
Times 24. Just because we have 24 hours a day. And we can pick up our lovely calculator. Without
8760.
87.
660.
60. Very good. So what's the growth factor? We should get more than that.
Plus.
Are we getting it? 8760. That's what the growth factor is. 1 plus 0.06 over 8760. And we're going to compute that. And I'm going to do a lot of digits because there is no way out. So I did that because I was patient today. 6183 6329. Okay, so let us compare it. So they seem to agree till here, 1.0683, and they differed a little bit after that. So it's a little bit more. Of course, it's not way more, but it's a little bit more. Okay, let us push ourselves one more step. And then you tell me stop it. Okay? What if I do it every minute? It means you can go and withdraw your money anytime, every minute. Not at the end of the day, every minute. Okay? What's the end? Now,
8760 times 60.
Times 60. So I have to show you how tedious it is and why people start, thinking what to do with this stuff. And then you do the math. And then the growth factor is going to be, now I want to do the math because I don't want this to be very messed up, 600. And then the growth factor, it means we just compute that to the power 525 600. And believe me, historically, people did those computations. They had no way out. That's why they start thinking, what we do with this mess? 8363. No, sorry, I'm copying the wrong number. So if we do that, we're going to get 1.0618367. And very soon I'll stop this madness. So what's happening here? How much do they agree? 836. So those two agree up to this decimal. And then they start changing a little bit. All right? I can push it. I can do it every second. I can do it every half second. But I won't because you will leave me. So the question is, as we compound more, this growth factor is becoming very, very close to each other. Is this making sense?
Yes. I have
Yes.
a question.
Yes, please, Roxanne.
Why would a bank want to give you compound interest daily or weekly? Why wouldn't they just do it yearly? I don't understand why anybody would offer to give you more money.
Usually the banks don't give you that.
Oh,
Usually,
okay.
that's to be very honest and very straightforward with that. The bank usually give you monthly, most of the time.
Okay.
Yeah, that's to be honest. But this is crucial to understand the meaning of E, where it comes from, and what's the idea of continuous compounding. I mean, if they tell you continuous compounding, they're basically telling you can come and withdraw your money anytime you want. I will give you a little bit more interest, but it's not really a huge amount unless you have billions and trillions of dollars. Then it may affect. But poor people like us, it won't affect them. So those who have those trillions of dollars, yes, it will. So now, as we realize, as we compound more and more, those numbers are getting very close to each other. You agree with me on that?
Yeah.
And then that's where the magic will happen. So people will start, that's where idea came. What is this number? Can I have a formula in a way, or can I have something that tell me what this number are? Because they are getting very close. And that's where the E comes into the picture. And that's why people introduce the number E, and they say they realize that this number it's going to become close to the following number. E to the power 0.06. It means those growth factors are getting close to e to the power 0.06. And let us check it out. Let us check that we are not really goofing. It means I want to compute e to the 0.06. Now, do you guys know, do you guys have your calculator?
Mm-hmm.
And then all of you, not only Roxanne, all of you. And I want you to compute e to the power 0.06.
Where's E?
That's why I want you to use your calculator. In my calculator, this is
Oh, I
my
see it.
E. That's my E. It's the same button as LN for, okay.
Oh, okay, I see it.
Now, beside Roxanne, are you guys figuring out what the E is? Talk to me on chat. Tell me yes or no.
Yeah, I got it.
Yes,
Anybody else?
I got it.
You're gonna use it, so I want you to know how to use it. So e to the 0.06. Now let us compute this number, and my calculator at least is giving me the following: 1.0618365547.
That's what I got.
So now I want you to see those numbers and e to the power 0.06, how much they agree with each other. Absolutely, they're almost the same. They differ after a million of digits, after 1, 2, 3, 4, 5, 6, 7 digits. So those numbers that becoming almost a nightmare to compute them, as you guys realize, what people figure out, and that's where actually, that's how people figure out the number E, where people figure out that those numbers are actually close to e to the 0.06. So instead, if we compound every day or every hour and every minute, instead of computing the growth factor using this formula, the growth factor is given by this number, e to the 0.06. And that's where E actually came up from. That's where the E really started. And then it took off because it was very important. So that's, but they realized e to 0.06. So now I'll go back and to my note. So of course, the more we compound, the more money we make. But also we realize that the growth factor are becoming extremely close in value. And the question is, what is this number? What is this number? It means, what is this? And the value is actually e to the 0.06. Means that's the maximum growth factor possible. Means if you keep compounding as much as you won't get a growth factor more than that. It means your money will not grow by a factor of larger than e to the 0.06. So if we invest 10,000 at an interest of 6%, compounded every minute or every second, we say that the interest rate is compounded continuously. So continuously, it means they keep compounding. And what's the amount of money after 10 years? So let us, so if you compound it almost every minute of every second, how much money? The growth factor will be e to the 0.6. It means every year, the money will be multiplied. That's the growth factor. We're gonna multiply it by 0.06. That's where the growth factor means multiplied by 0.06 every unit of time. So it means after 3 years, we're going to have the initial times e to the 0.06 to the power t. Because that's the b. That's the b. That's what we are multiplying, because as time increases by 1, the money is multiplied by e to the 0.06. So it means that's how much money we're going to have, 10,000 e to the 0.06. And that's what I'm trying to tell you here. So the amount of money after 2 years is going to become the initial e to the 0.06 to the power t. Now, this is hard to memorize. So an easier to memorize is by using back algebra. And power to a power, you multiply the power. So it's 10,000 e to the 0.060. And that will be the maximum. I mean, if you, that's the amount you will make, the maximum amount of money you can make by compounding. You cannot make more than that, because this is assume you're compounding every single minute. If the bank gives you that, it means the bank is telling you that's the best kind of compounding possible that exists. So let us summarize those. So this is not a hard section. It actually makes intuitive sense. So summary. Suppose you invest P dollars at an interest rate R, and F of T is the amount of money after T years. Then, if the money is compounded N times a year, 12 times, 365 times, then the formula is what you've seen before. And the growth factor, it means by how much, by what number it's multiplied every unit of time, is this piece right there. That's the growth factor. That's the growth factor. You can memorize the formula, or you can understand how we can pick it from. If the money compounded continuously, it means in my mind, in your mind, it's compounded almost every hour. Every hour you get interest on your money. Then the formula becomes your initial e to the RT. R is what we call the nominal rate. And the growth factor here is e to the R. So the growth factor is this piece right there. That's how I visualize the growth factor. That's e to the R. That's really the growth factor. So we finalize this section with a example. Again, a simple example. So whatever. Okay. Suppose you have 3,000. You're invested in an account that paid 2%. And find the amount of money after 2 years, after 5 years, if compounded annually. So I always start compound annual to remind you that you know what happened in annually. So compounded annually, it is really actually kind of simple. So compounded annually, it means after 2 years. Sorry. After 2 years, it's the initial. It's compounded annually at 2%. It means 1 plus 0.02 to the power t. So that's the basic formulation. If it is 1 year. After 5, it means you take t equal to 5. It's going to be 3,000, 1.02 to the power 5. And, you know, we can compute. Those are easy to compute. So we get 3,000.24. Now, what is about compounded continuously? Okay. How does the formula work? Tells me that after 2 years, the amount of money is 3,000 times e to the power RT. R is the rate put in decimal. R is 2%, 0.02.
Go down.
What?
Can you move down? Yeah. All right.
Yes, thank you. Thanks a lot. RT, it means 0.02 times T. That's how we use it. This is my R times T. That's how much money we will have after 2 years. How much we will have after 5 years. It means T is 5. So it's 3,000 e to the power 0.02 times 5. That's become my new power. All right, so let us compute this. And you guys compute it without looking at my notes, because I want to make sure you can compute it correctly. If I am doing this problem, sometimes I like to compute the power first, because it's a simple power. And if I compute it first, I will not risk doing mistakes. So 0.02 times 5 is going to give me 0.1. And then I compute, I don't know. So 3,000 times e to the power 0.1. Now, I know I should get a little bit more than that, or not more, but a little bit more. And that's give me 3,300. So I'm basically doing exactly what you guys are doing. With me?
Yep.
Yeah, so that's what I'm getting. So 3,015.51. So that's really what I get in this scenario. So a little bit more than that. Not much, but a little bit more. Now, my last question is, find the effective rate in both scenarios. If it's compounded annually, there is nothing to do. Compounded annually, my effective rate is 2% because that's how I'm getting after 1 year. Now, it's compounded continuously. It means, of course, I'm getting more than 2%. Because if I get 2% after 5 years, that's how much I have. But since after 5 years I made more, it means I'm getting more than 2% per year. That's the effective rate. So what's the effective rate? So it's continuous compounding, the effective rate, sorry, the growth factor first. The growth factor is the e to the power 0.02. That's not the rate, that's the factor. It means by how much we multiply every year. So which is equal to, and I will compute that, e to the power 0.02, which is 1.0202, and then it's 0. I'm going to stop there. It means the effective rate is going to be the growth factor minus 1.0202. It means 2.02%. So this tells me by how much we multiply every year, and this tells me effectively I'm getting 2.02%. So 2% compounded continuously is equivalent to 2.02% compounded annually. And as I said, that's the one that the bank give you because that's the one we understand. It's hard to figure out 2% continuously. You know, we call it nominal rate because we actually want to know annually how much we're getting. And that's really annually that sometimes the bank called the yield, which is exactly what you're getting per year. Okay, questions?
No.
Anybody else? Patrick, Brandon, all of you. You know, I know all of you right here.
Yep, I don't have any more
Ethan,
questions.
Lily, anybody?
No.
Okay. So today we're gonna move. So those are we're gonna assign problem along those lines. And today we're gonna move to basically the last chapter in this course.
Oh yeah.
Come on, Roxanne. You're not enjoying it?
No, I'm so waiting for school to be done so I can focus on work.
Okay. All right. So the last section, the last chapter we're gonna talk about is the logarithm. And first, let me tell you what's the goal of this section eventually, and then we start working with it. So we've been investing money, and let us say we invest, let us say $500 in the bank. And the bank give us per year, I'm not thinking compounding now, and the bank give us an interest rate of like, let's dream now, 5%. Okay, and so after 2 years, you will have that much. Then you ask yourself, okay, you want to ask yourself, how long would it take for my money to grow to 600? So you start with 500, 5% per year is after 2 years, that's how much you have. So that's after 2 years. So you're going to ask yourself, how long it takes for my money to grow to 600? So now you want to solve for t, it means you're going to solve for the exponent, which is not exponent, which is not an easy problem. I'm going to find the number t here, so that if I take this to the power t equals 600. So our goal in this section is basically to solve for the exponent, this t. So we're going to learn a lot of techniques, to be able to solve this. It's not really a trivial problem. I mean, I can give you something very easy before we hit algorithm. Suppose I'm going to give you the following problem. Solve something simple. I don't know, 10 to the t equal to 120. Do you think it's an easy problem to solve?
No.
Give me a value, give me a range for t. Give me a
One.
range. Is t 1? Can
no.
t be 1?
It's
10 to the power
larger
1
than
is,
2,
zero.
smaller than 3.
is t bigger than 2? Yeah,
No.
because 10
Well,
squared is 100. Makes sense. Is t less than 3?
Yes.
Yeah, because 10 to the power 3 is 1,000. So t is somewhere between 2 and 3. I'm just showing you the difficulty of those problems. So that's the only thing I know. It's not 2, it's more than 2. It's not 3, it's actually less than 3. Because 10 to the power 3 is 1,000. So what is this t? What is really this t? It's not a trivial problem. I can do guess and check, which is a pain. So I can try, I don't know, 2.1. Is it anywhere close? You see what I'm doing? I'm just checking before I introduce the idea. So let me see if t equal 2.1 would work. So if I take 10 to the power 2.1, I am getting 125. Not bad. So is t bigger than 2.1? What?
So it's less than 2.1?
It's less than 2.1. It's less than 2.1. So I can try 2.09. And so the only thing I'm doing now is trial and error, because that's all I can do. So to show you why we're going to study what we're going to study. So if I take to the power 0.9, sorry, to the power 2.09, I got 123. I can keep this. I can try 2.08 and I figure it out. So it's not basically an easy problem. So the question is, okay, how are we going to solve this? How are we going to find this t? And to be able to do this, people had to introduce a new function, totally new, that we haven't seen it before. We've seen x squared, the quadratic. We've seen exponential. We've seen linear. So they introduced a new function and they gave it a name. They call it the log. And what is the log? Before I go back and talk everything in a more precise way. What is the log? So they're going to define something called log of 120. What is the log of 120? The log of 120, we're going to define it to be this power t. It's going to be the power of 10. Sorry, the power of 10, such that when I take the power of 10, that gives 120. So we're going to define log of 120 to be this power, such that I take 10 to this power, it will give me 120. So we're going to define log of 120 to be this t that I am after. That's what the log of 120 is going to be. It's the power of 10 that's going to spit out 120. And our calculator are equipped with that. So it means if we take our calculator, I want you all to locate LOG on your calculator. All of you. All of you. And compute log of 120. And what do you get?
2.07918124.
Exactly. Because the calculator tells me it's 2.079. That's what the calculator tells me. It means if I take 10 to this power, we're gonna get 120. So the log of 120 is gonna be the answer to our problem. It's gonna give me this t that I tried hard to estimate. It's gonna give me this t, so that 10 to this power will give me 120. And that's the importance of this new function that we're gonna introduce, and where almost the only way we're gonna find its value is by using the calculator. So that's what the idea of the logarithm is about. And now I start the logarithm. Okay. Well, it's not hard at the beginning, actually. It's not really hard at the beginning, especially today. It's not going to be hard at all. So what is the logarithm? Let n be a positive number. And very soon you will tell me why I need that. The log of n, we denote it by log of n. The notation is important. Is defined as follows. What's the log of n? Is the exponent. So the log is the exponent of 10 that gives n. So log of 120 that I was talking about a minute ago, so the log of 120 is actually the power, the exponent of n, the exponent of 10, that will give me 120. So the definition of the log is the exponent of 10 that will give me 120. So log n is what? Log n is the number, it's the box that has the property 10. When you take 10 and you raise it to the power this box, you get n back. In short, log of n is the number. Whatever the number is, it means log n equal the box. It means 10 to the power this box will give me n back. And now let us practice this definition together. Now, I did not put those notes on Blackboard for a reason, because I want you to work with me. And then after you work with me, I will put those notes on Blackboard after I finish. So, because I want to work, you guys have to answer the question. So I'm going to start with the following. What does log of 100 means? Log of 100 is the number. That said, when you take 10 to the power this number, you get 100. That's what the log is. It's this power. Okay, now Roxanne answered this question. I want all of you to answer this question. 10 to which power will give me 100?
Second power.
To the second power, which means that the log of 100 is actually equal to 2. So I don't want you guys to use your calculator for now. Put them all on the side. Just work with me, and I'm going to ask different students to answer the question. So what is the log of 100? Is this power. That's what I am after. As a 10 to this power spits out the inside. Spits out the inside. All right, let us play the game a little bit of this log. So I'm going to give you a bunch of logs, and you guys will give me the answer. And I will cycle through the student. What's log of 1? Please do not use your calculator. Try to understand. It means I'm looking for something. Such that when I take 10 to this power, I get a 1. All right? Who would
I
like
know.
to... Okay, not you.
0.
Somebody said something correct. Speak up. Speak up.
0.
0. She's absolutely correct. Why?
Anything to the 0 power is 1.
Right, because 10 to the power 0 will give me a 1. So log 1 is equal to 0. And that's why. 10 to the power 0. So the log is this power here. That's what the log is. It's the power. Crucial to understand this. All right, I keep playing the same game. Again, easy number. What's the log of 10? It means, again, I am asking for the power of 10.
1.
That it's absolutely 1. Because 10 to the 1 equal to 10. So that's what the log of 10 actually means. It's this power. All right. What's the log of, okay, 1 over 10.
Oh.
The negative 1.
To which power give me 1 over 10?
Negative 1.
What? Negative 1. Absolutely correct. It's negative 1 because 10 to the negative 1 is 1 over 10. Okay, so my goal now is to build some kind of feeling of what those is. Okay, let me keep playing this game. Don't be afraid. As long as we understand that we are looking for the power, you will be in a good shape.
1/2.
1/2. Anybody agree?
I was about to say that thing.
Oh, so because what's the square root of 10? It's 10 to the power 1/2. That's what we talked about a lot about those fractional exponents. So this is going to be equal 1/2. It means if you pick up your calculator, that's exactly what you're going to get. All right, more of the same stuff, more of the same. What is the log? But please don't look your calculator because I'm not testing you. That's the problem. I cannot test you on those without a calculator.
-2.
-2. You're reluctant. You shouldn't be. Justify.
What's that? 1 over what? I can't see.
100. I'm sorry. 100. This is 100. Okay. So basically, I'm asking you 10 to which power will give me 1 over 100. What should I put here to get 1 over 100?
-2.
-2, because absolutely correct, that's -2, because 10 to the -2 is 1 over 10 square, which is 1 over 100. So the log of that is absolutely -2. All right, 3 more examples along the same line. It's the power of 10. I mean, 10 is important. It's not the power of 2. It's the power of 10. So let us say I give you the log of 1 over, let us say, the cubic root of 10. That's what I'm looking for. So I put in front of me what I'm looking for so I can really make sense out of that.
Is it -2/3?
No, you're forgetting your fractional exponent.
3/2?
Oh boy.
I don't know.
-1/3.
-1/3.
Right, -1/3. Let us remember. What's the end?
Oh,
Yeah, the nth root of a is a to the 1 over n. It has nothing to do with 10/2. Square root of a was nothing. It's a to the half. The nth root is a to the 1 over n. There is no half in it. So this is going to be equal to, so this, before I put the power, I need to write 10 to a power. To be able to find this, I need to write this to a power. So this is 1 over 10 to the power a third. But I need it in the numerator, it's 10 to the minus a third. So my power here is minus a third. So this is minus 1 over 3. Okay? All right, so more. What's the log of 0? It means 10 to which power? I get 0.
0? No. Nothing?
Nothing.
Undefined?
Undefined, 100% correct. Why it is undefined? If I take 10 raised to any power, there is no way I can get a 0. If you just make it short. If I take 10 to -1, that's 1 over 10. 10 to the -2, 1 over 100. 10 squared is 100. So if I take 10 to any power, whether the power is positive or negative, there is no way I can get a 0. So this is absolutely undefined. Because 10 to any power is different from 0. Whatever the power is, this can never be equal to 0. So log 0 doesn't make any sense or whatsoever. So another one, what about the log of -2? Because
You can never get -2.
we can never get not only -2.
Any negative number.
We cannot
Anything
get
less
any
than
negative.
0.
Exactly. We cannot get any negative number. If I take, so I repeat what the chart I put here. 10 to any power, regardless what the power is, will spits out a positive number. Whether the power is negative or positive, the number is positive. If the power is like -1, it has nothing to do with negative. It's just 1/10, which is a positive number. -2 is 1/100, which is another positive number. Square is 100. So 10 to a power, the exponential function is never takes negative value. So log of any negative number is absolutely indefinite. Okay, so this is some kind of practice, and this is because 10 to any power, let's call it the power x, is always positive. Always positive, and it's never equal to 0. All right, now a little bit more questions along the same lines, and my question is the following. Okay, more practice with this notation. Okay. Suppose I tell you the log of 15, so I pull out my calculator, that's what I did actually, and I compute the log of, so first I need to turn it on, and I compute the log of 15. And I tell you log of 15 is 1.176. So I a little bit, what does this mean in terms of exponent? What does this mean to you?
Would it be like growth rate or growth factor?
No, I'm not asking that. No.
10 to the power 1.76
Right.
equals
Yes,
15.
it means if you take 10, no, I'm not asking those type of questions. My question now is to try to understand what does this mean? What does this new thing, I call it log, really mean? So if I put log of 15 equal this, it means what am I telling you? Is if I take 10 and I raise it to this power,
15.
I get 15.
Same.
Exactly. So it means that, back to my lovely calculator, it means if I take 10 and I raise it to the power 1.176, this calculator should give me almost 15. It gave me 14.99 because I rounded to 1.76. Okay, so 10 to the 1.176 equals 50. So again, rewrite this, so the same type of question. If I tell you log of 200 is equal, I don't know, I pick my calculator and I compute log of 200, 2.301. What does this mean in terms of exponent? It means if you take 10 and you raise it to this weird power, you get 200. So that's what the log of a number is. It's the power of 10 that gives you 15. Log of 200 is the power of 10 that gives you 200. So now I'm going to give you one more. Suppose I tell you log of t is equal to 4. What is t? Or rewrite this using exponent. Rewrite this expression using exponent. Log t equal 4. What does
10,000.
this mean?
Yeah, the fourth power. Like,
10,000?
oh,
Yeah, it means 10 to the power 4. You're right. 10 to the power 4 is equal to t. It means t is 10 to the power 4. It means if you take your calculator and you compute log of 10 to the power 4, you get 4. Of course, we knew that because that log of 10 to the power 4 is equal to 4. So now I'm gonna, the first simple rule, not rule, it's something that, before I write it, let me tell you. Suppose I take 10 to the power log of 200. What should be my answer back? What do you think should be the answer?
That's confusing.
I know.
Would it be 2.301?
I know confusing, but we have to get it done. I know it's confusing.
2.301.
What?
2.301.
No. What's 10 to the log 200? Let
Go
us
to
go back.
Would
Let us
you
go.
have to multiply them together?
No. Let us go back. What's the definition of the log of 200? What's the definition?
2.301.
That's 2.301.
Right.
Okay, what does 2.301 represent?
It raises.
Power of 10. That should
Oh,
give me
the answer's
what?
200.
Yeah, that should give me what?
200.
200.
200. That's the definition of the log of 200. Is what I should put here so that it will spit out 200. So if I take 10, this whole thing is a number. What's the job of this number? 10 to the power this number will give me 200 back. So we're seeing the first property of those. So now I can repeat. 10 to the log 15. It means if I take log of 15, I compute it and I plug it back here. What should I get? I get 15 back because that's the definition of log 15. It's the definition. It's not, that's what this log 15 is. It is this power of 10, such that take 10 to this power, give me 15. So why this is true? Because that's the definition of this number. So when I wrote log 15 equal 1.176, the 1.76 is this power of 10 that gives me 15. So the first confusing rule about the log is the following. If you take 10, you raise it to the power log of any number, so that's become your power. So that's the power. This will give you your number back, as long as your number is positive. But that's the definition. The definition of the log is log of n is the power of 10 that give you n. So to force you in a way to interact with that, because as Roxanne said, that's confusing, I want you to pick up your calculator, all of you, and let's play with that. I want all of us to compute 10 to the power log of 2. Because that's the power. So it means I'm going to do the first one. It means 10. Watch what I'm doing. To the power. Okay? Log of 2. Close my parentheses. What this should give me back?
2.
2. That's 2. The 10 to the power log of anything will give me the anything back, because that's the definition of the log. It is the power of 10 that gives me what's inside 2. So let us play this game again. Now you guys plug it into your calculator and make sure you can get your calculator working correctly. And do it the way I'm doing it. So put everything with it, so we're not estimating. Anybody?
3?
Are you getting 3? You have to get. If you don't get 3, it means somebody is wrong. And math is not wrong. We have to get 3. So that's really the property of the log of a number. So the log of a number is the power of 10 that will give you n back. So that's really what it is. It's what should I put here? So when you compute that number, it's telling you what you should put here to get the n back. And because of this definition, because that's what the definition is, 10 to the power, the log n will give you n back, because that's the definition. There's no other explanation for that, because that's how I define this number to be the power of 10 is equal to n. Okay, so that's the first idea about this, the log of n. Now, along the same line, nothing different, but fairly close to the same idea is, when I define the log of n, I said, okay, it's the power of 10 that gives me n. All right. And this log is written log, log. Now, there is another log that we call the natural log. So there is another logarithm we call the natural logarithm. And tonight, everything I'm saying will be on Blackboard tonight. Okay, natural logarithm. What is the natural logarithm? The definition is the same. But instead of 10 here, we're gonna put e, the famous e number. So the natural logarithm usually denoted by ln of n. So what's the difference? This is log of n. That's usually called the common log. The natural log is ln. So there is way, we write them in a different way. What's the ln of n? Is the exponent of e, or the power of e, that give n back. So what is ln of n? It's the number in the box that has the property e to the power this number gives me n back. So instead of 10 to the power, the ln is the power of e that gives you n back. Log n is the power of 10 that gives you n back. And to be honest, the one that you will use the most is this one, more than the first one. This is going to be used tremendously, a lot. So let us play again with that. So suppose I pick up my calculator again, and I want you to locate the ln button on your calculator. You guys locate it.
Found it.
Got it.
Slowly. Yeah, take your time, take your time. So on my calculator is where the ln is right there. You see it. I don't know, each calculator is different.
I got it.
I want all of you to get it. And after you get it, I want you to find ln of 2. Just to make sure we're on the right track, all of us.
.6931.
That's my memory, 0.6931. So now I'm gonna do it with you. So ln, I hit the button of 2, close my parenthesis, 0.693147. Okay, what does this number mean? So I can put ln of 2, all of us, you got this weird number. It means that if I take e is a number, and I raise it to the power 0.6931, this will give me 2 back. That's the difference between. So the 0.6931 now is the power of e that's gonna give me 2 back. So if now I can go again here and check. It means if I take e, the second e, to the power 0.6931, this is going to give me 1.9999 because I rounded. I did not use the whole value. I just rounded it up to here. It's going to give me 2. So the ln of 2 is now, instead of being the power of 10, it's the power of e that gives me 2. So let us see the difference between them. And I stop after that. Log of n is the power of 10 that gives me n back. ln of n is going to be the power of e that gives me n back. So if I ask you what is ln of e, what should we get? What am I asking you?
Should be 1, right?
Yeah, it's the power of e that gives me e. That's where I get my 1. So this is going to be a little bit harder to work with than the log because it's E. It's easy to work with 10, but this turned up to be the one that we're going to be using more. So suppose I tell you what's ln of 1 over E. Remember, 1 over E is a number. It's just a number. It's 1 over 2.7 something. It means, again, E to which power gives me 1 over E. I know there's so much symbolism here, but it's so there isn't much I can do about it.
Would it be -1?
It will be -1. It's like before. It's absolutely like before. So what is ln of the square root of E? Remember, square root of E is nothing to be afraid of. It means the square root of 2.718. That's what it is. That's what the square root of E. So it means E to which power? You get the square root of E. Exactly. It's a half. That's a half. So the ln is basically, the definition is like the log, so we work with it in the same way. The difference is that I am not after the power of 10, I am after the power of E that gives me what I want. We're gonna use, the next time, we're gonna study a lot of the properties that this new thing has that we call ln, and we're gonna go back to my original problem and learn how to use this new acquired knowledge to solve my problem. I've invested my 585%, and what's the time, after how long it's gonna take me for my money to go to 600? This is really my original problem. So we're gonna use what we're gonna be learning and get back and solve this initial problem that I started. Okay? So at this stage, I stopped today, and what I did right now, I'm gonna put it on Blackboard, but I did not wanna put it on Blackboard because I want you guys to work with me. If you have the answers, it doesn't really help me much, okay? All right, for next time, as usual, you're gonna have your quiz, and you're gonna have quiz about what we did today, which is gonna involve effective rate, continuous compounding, and a little bit of that. Not much for the first quiz. Another thing about your exam, you guys have the grade and you guys have the correction. I was planning to put the solution on Blackboard, but then at the last minute, I decided I didn't want to. And for the following reason, since our final exam is coming up, so it's crucial that all of you can solve this exam correctly. So, due next Monday, I'm very clear now, due next Monday, I'm gonna put the exam back on Blackboard, and I want you guys by yourself to do it all over again. Now I have a lot of students, not a lot, I have a group of students who got above 90. Those are fine. I'm not really concerned about them. I'm more concerned about the students who got below 90. Let's get that straight. Due next Monday, I want you to do the exam all over again. You read my comments, and you do the exam. And I'm gonna open it on Blackboard like usual. And it will be graded like a quiz. Is that clear?
So yeah.
It will be worth 20 points.
Okay.
All right, that's the idea. So the idea is clear. And then later on, I'll give you the solution. I wrote the solution. I wanted to scan it and I stopped. I said, I want them to take, so it's next Monday, so you have time and you guys can ask me any question you want. The main goal for me is that you guys work on it. So for next Monday, I'm gonna open it on Blackboard. I'm gonna put it on Blackboard so you guys can start working on it again. And because you have your final exam, and it's gonna be, a lot of it will be on your final, I want you to do the exam, turn it in on Blackboard, not by email, because you're gonna have all the time you need. And I will grade it like a quiz. And it will be worth 20 points. So it's just like a quiz, I will grade it. For those who got above 90, it's your choice. You can do whatever you want. But I'm really concerned about the students who actually didn't do well on this quiz and the exam. And I want them to learn this material. So that's about the exam. Once I have all this in and you guys correct it, and then I'll put the solution and later on I will discuss it. But I don't want to put the solution now, but I want you guys to read my comments and see if you understood anything from them and redo the exam. Am I clear about that?
So
Yep.
is it like an extra 20 points? Pretty
Extra
much?
quiz, extra quiz. Okay, so like, and I don't know how many quiz I'm gonna end up with. So this will be like an extra quiz for you. If you get 20 points, so this quiz will not be dropped. So this will give you, more ways to compensate a bad quiz if you want.
Can you make it extra credit?
I can make it extra credit. It will be extra credit for those who got above 90. Every student below 90 have to do it. It's not extra credit. It's gonna be a quiz. Absolutely a quiz. No, actually a quiz for everyone. No extra credit. It's going to be a quiz for everybody. It will be worth 20 points. And the goal is clear, because if you do it again, you learn it, you're going to benefit for your final exam. That's my goal. I don't have fun grading, believe me. Is that clear?
Yeah.
Okay. And you can ask me questions, like you can guys meet with me on my office hours, on Wednesday, or you can tell me I cannot, I can fix office hours with you. I want you guys to take this exam and rewrite it again and learn from it. And this will be a good review for your final. That's the way I'm looking at it. All right. Any questions before I leave? Anybody? So I'm gonna this is gonna be on Blackboard. And the way it always is, you guys go there, do it, scan it, and upload it. All right? Any questions?
Nope.
And please join me in my office hours. So just do it. I mean, you still have 3 weeks, and I can help you in those 3 weeks. Okay. Good night, guys.
Good night.
Good night.